Your Highness, the CEO of the Saudi Industrial Development Fund, Prince Sultan bin Khalid bin Faisal Al Saud, distinguished guests, ladies and gentlemen, good afternoon. My name is Dima Abdel Hafid from the Market Studies Department, and I'll be your host today for our first session of Knowledge Month of 2025. We are pleased to welcome you to the opening of the 5th edition of Knowledge Month. This year, the edition is held with the support of the Saudi Advanced Manufacturing Hub. We are also honored by the presence and participation of Mr. Jeremy Jurgens, Managing Director of the World Economic Forum. This year's edition will feature specialized workshops covering various industrial sectors, with the participation of experts and industry leaders to exchange knowledge and insights. We hope that this year's edition will be another step forward towards a more sustainable and advanced industrial future. Now, I would like to invite Engineer Ahmed Al-Baghawi, Executive Vice President of Studies, to deliver the opening speech.
Assalamu alaikum wa rahmatullah. Good afternoon, everyone. Thank you. Your Highness, the CEO of the Saudi Industrial Development Fund, our esteemed partners from the public and private sector, my colleagues at the Saudi Industrial Development Fund, distinguished guests, Mr. Jeremy Jurgens. It gives me great pleasure to welcome you today to celebrate the launch of the 5th edition of Knowledge Month at the Saudi Industrial Development Fund. Empowered by the Saudi Advanced Manufacturing Hub, Saudi AM Hub, with the aim to foster a culture of knowledge exchange, sharing expertise, and strengthening collaboration across the industrial ecosystem. Throughout Saudi Arabia's industrial journey, knowledge has always been the link between ideas and implementation, between ambition and achievement. Today, through Knowledge Month, we continue to build a nation that believes that investing in minds is the truest form of investment. We firmly believe that knowledge is the cornerstone of advancing the industrial sector, enriching competitiveness, and driving the national economy towards great progress and sustainability. Knowledge Month has become an annual milestone we take pride in at SIDF, embodying the culture of continuous learning that we uphold high at SIDF. It serves as a platform for exchanging expertise, exploring global industrial and technological trends, and reaffirming SIDF's role as a trusted source of industrial knowledge and experience. Over the past editions, we have held almost 70 workshops featuring 275 experts and speakers from various organizations across the globe, and has welcomed more than 18,000 participants from across the industrial ecosystem. This year, we are excited to present 14 workshops that will be held in person and through live streaming, with the participation of leading experts in various interesting topics such as advanced manufacturing, artificial intelligence, financial technology, supply chain, data governance, and legal and economic dimensions in the industrial sector. On behalf of the CEO and the executive team, we would like to extend a sincere appreciation to all our SIDF members and colleagues, officers and position holders, who have dedicated amazing time and effort in organizing this program year after year to attract distinguished group of experts and speakers whose contribution enrich the fund's knowledge and support the advancement of the sectors that we proudly serve today. In conclusion, we invite all of our colleagues and our partners from the private and public sector to take advantage of the workshops, the discussions, these events throughout the entire month, as they will no doubt have a lasting impact on shaping a more advanced, sustainable industrial future. Now, I am so delighted to kick off this first session of the Knowledge Month with the participation of the Advanced Manufacturing Hub. Thank you.
Thank you, Engineer Ahmed, for your inspiring words. Now we invite Mr. Jeremy Jurgens, Managing Director of the World Economic Forum, to talk about the global megatrends in advanced manufacturing and the role of emerging technologies in reshaping the industrial landscape. Please join us.
Your Highness, Your Excellencies, distinguished guests, Ahmed Dima, thank you for hosting me here today. It's a great pleasure. This is, I believe, my fourth time here at SIDF. I had the privilege of meeting His Highness for the first time in Turkey several years ago, and since then have made it part of my regular visits to come and just see the continued growth and development that everybody here in the team is doing. And I just think it's amazing. And last year, I was introduced to the concept of November. And what the AM Hub here is now helping put together. And I was like super intrigued and said, well, when you're next time here, why don't you do it? So I tried to plan my visit this time so we could start November early, right? So I think it's like everything else happening in the economy. It's moving very quickly. So, I wanted to touch on building on the experience that we see at the World Economic Forum, my interactions with CEOs, policymakers, and technologists from around the world, and seeing if we could actually synthesize some of that and highlight some of the key megatrends that we should be thinking about. So we've put that together here, and so what are the leadership priorities? A little bit of discussion on compounding combinatorial effects that we see taking place, the emerging technologies that emerge, what the implications are for business leaders, implications for advanced manufacturing, and if we have time, some considerations for Saudi Arabia. I always believe that it's better to leave a room with still having questions rather than having all the answers. So we will go quickly today. So if you're like, this is moving very fast, it's to actually trigger your own curiosity and your pursuit of knowledge and discovery rather than trying to condense all of this here. It's really a starting point for you to continue your own learning and exploration there. So let's jump in with the strategic leadership priorities here. I think consistently, these are the kind of 5 big themes that we see globally when I talk to leaders. And you could have gone back 5 years ago, 10 years ago, 20 years ago. A lot of them that were the same. Different aspects to it, and we'll just dig into this a little bit here. Geopolitics. Of course, we've been watching the terrible wars that have been taking place in Ukraine, in Gaza. But according to the International Institute of Strategic Studies, there's more than 168 ongoing conflicts around the world today. So conflict, unfortunately, has become a constant in the economy and geopolitics. This is a image of a cruise ship sitting off the coast near Panama, where we've seen the U.S. recently conducting strikes against what they consider terrorist groups bringing drugs in. 3 months ago, this wasn't taking place, right? So it's just a new vector for conflict there. And it's something as a business leader, you have to be continually monitoring, and we heard about supply chains earlier, you have to be thinking around across the global system there. Economy. Economy is booming here in Riyadh. Great to see. We've been hearing discussions about the end of the AI bubble, the semiconductor bubble for a couple of years now. It's not here yet. We'll come into that a little bit more. But supply chain disruptions, tariffs, inflation, COVID, conflict. Again, change is the new normal, right? You have to be prepared for just continuous and constant disruption and continually reassess your plans, what you do there. You can have a 5-year direction, but be prepared to adapt. Don't be, fixated on what's taking place there. And we see this in the economy as well as in geopolitics. Climate and energy. This is a solar field in Saudi Arabia. Experts today think, the target of 1.5 degrees is pretty much unrealistic, at least all the scientists that I speak to. And we're much closer to being on track for somewhere between 2.4 and 2.8 degrees. And with that comes increased droughts, increased wildfires, increased floodings, and massive disruption. So even as we look at how do we adapt the energy system and look at how we balance the energy demands for a growing society, growing economy, for 8 billion people going on 9 billion. We also have to take into account, okay, how do you manage the climate implications of that and the broader natural ecosystem? Demographics and people. Anybody recognize this square here? It's Shibuya in Tokyo. Has one of the lowest birth rates in the world, right? So you see an entire economy trying to adapt to that. And then other places we have skills shortages, right? So declining population. And I actually pulled up some numbers here before I came. And just to get them right so I don't misquote them, because I found them quite surprising. So the UN estimates that we would peak around 10.4 billion people from the 8.2 billion that we are today. Now, half that growth is expected to come from just 8 countries, right? So 5 are in Africa, plus India, Pakistan, and the Philippines, where most of the developed world is on the same course as Japan, with declining population. So you end up getting tensions in this differential allocation of where people are, where the youth are, where the skills are. And then that also has geopolitical implications, demographic implications, and also on energy consumption and demand there. Now, frontier technologies, these are the ones that I personally consider kind of the 6 most significant. There's other things out there, crypto, we heard about financial technologies earlier, but I think these are the 6 that I consider most important. And one of the reasons is because I'm looking at which are the technologies that you see rapidly compounding capabilities and that have potential to combine across other domains. And so I'd like to go back to history just to show what the implications of this might look like. So this is a computer from IBM, the IBM RAMAC 305. At the time, it had 5 megabytes of storage. Cost $34,000. You leased it, like you might lease your Lucid car. Weighed a ton, a little bit less than the Lucid, so that's a good thing there, 900 kilos. And it was 2 meters, by a little over a meter, and about 60 centimeters in depth. And so this is 1956. That's the same year that the word artificial intelligence was coined by John McCarthy. It was also the same year as the Suez Canal crisis. Now, during that time, we've seen rapid changes in the growth of what storage can do, yet shipping is still having challenges moving through the strait, right? So you have a exponentially changing world going around interfacing with a world that isn't changing at an exponential rate. What does this look like concretely? Well, to describe it, what 1 terabyte of storage would have cost us in 1956 would have been over $100 billion for a terabyte. And we've seen this rapid decline. And we know that when we see a log chart, the growth is so rapid that we need logarithmic scale to measure that change. And so when I'm thinking around technologies, business, opportunities, risks, I'm always looking at changes that you would graph like this on a log chart rather than on a standard linear graph. But it's hard for us to internalize this kind of thing. We're not wired to think in exponentials, and we're not wired to think in probabilities. These are just 2 things that the human brain isn't set up for. So another way is we can try and image that. We make an analogy. So now I have 1 terabyte of storage, costs me $50 US, and it's 1 gram. Okay, I blew it up here so everybody could see it, because otherwise it's a little bit larger than my fingernail. Right? So, and our first temptation may be to compare this terabyte with the 5 megabytes. right? The volume, the size, the cost. But the difference between 5 megabytes and a terabyte isn't actually captured here. A better way is to have, actually it would be 2 terabytes of computing, a little over 2 terabytes of computing. If you were using these computers, it would take the total volume of the Burj Khalifa. Right? And so, again, mentally, that's a change that we've seen in the lifetimes of people that are with us today. Now, back to this thing, a caveat. Not everything is linear. This is the first transatlantic flight, Pan Am 101, went from New York to Paris, but it had to stop in Newfoundland for refueling because it didn't have quite enough fuel there. 2 years after that, that hard disk was launched there. And this is Southwest, I think in 2017, 2018, 10,000th 737, most popular jet ever. It's a little bit faster than the other plane. It carries a few more passengers. Actually, per passenger, it's a lot more expensive than it was then. And so again, you have a exponentially changing world interfacing with a non-exponential world. And so as a business leader, you have to ask yourself, where can I unlock or where I harness those potentials? Now, I think AI is a good example of this, right? So we have compounding capabilities, but then there's also the combinatorial aspect. So in the case of semiconductors, this is the NVIDIA GB200, also blown up to scale for the group here. Been improving on an exponential rate. We'll come into that in a moment. You have algorithms also improving on an exponential rate. And you have data, which you need for the latest deep learning models, also becoming available at an exponential rate. So what happens when you combine 3 exponentially compounding capabilities? You get super capabilities, right? So you look at this chart that we're going from, early 1940s up to the today, and even these charts aren't up to date because today we're seeing every week new capabilities coming out, right? So even on a log curve, this becomes super steep, meaning dramatic change, right? And this is the world that we're living in and that we're doing. Last comment on compounding and combinatorial, and this is why I like November, because knowledge is also compounding, and our collective knowledge is combinatorial. So if we can take our collective knowledge, the combinatorial capabilities, and interface that with machine intelligence, other technologies that are also compounding, we can have superpowers, as it may be. Now, this is from earlier this week, Jensen Huang. This picture is worth $5 trillion, right? That's what NVIDIA reached this week. Now, I wanted to make sure this was up to date for the group, so I went and looked for a few numbers just to put this in context. So this is a company that actually was founded the same year that I graduated from university, 1993. So unfortunately, I'm not worth $5 trillion, but got a better investment with NVIDIA than my mother did. Now, if you think at the speed at which that's been changing, so it was 6,138 days to reach the first $1 trillion market cap, which is already extraordinary. The second trillion was in 180 days. 66 days to get to $3 trillion. 273 to 4 trillion, were they slowing down a little bit? Yeah, maybe. But you're not really seeing, declining marginal returns there. And now we're at 78 days to $5 trillion, right? So in just 78 days, it's gone that. And I know Aramco, we were discussing earlier about Aramco. Today, Aramco is the only non-tech company in the top 10 by valuation. And from roughly 10,000 listed companies, the top 10 tech companies make up over 20% of that global valuation, right? And if we'd gone back just 15 years ago, it would have been big banks like JP Morgan, like Aramco, like Exxon. And they're still relevant. They're still massively successful companies. But it's these companies that are actually harnessing exponential technologies that are actually displacing it. Now, I want to go into a little bit deeper dive into semiconductors here. I'll just check the time to make sure I don't run over too long here. We'll speed it up. Now, 1.5 trillion semiconductors, sensors, transistors produced last year. So yeah, the Blackwell chips, maybe $70,000 for one of those, but you can buy a Raspberry Pi for $30, and your children can actually build their own computers with that. And so we're moving into this world of pervasive and ubiquitous computing. And now if you think about manufacturing, that means you have sensors everywhere, you can have compute everywhere, and you can have distributed and embedded intelligence everywhere that we go. We also start to have domain-specific processors. So rather than using a general GPU, we can actually have a GPU that's just specialized for this. As the costs fall, as the scale goes up, it means that very specialized compute can be distributed across a range of different types of activities, and you can then get more power, more capability in from a very specialized processor. You also have in-house design. Why take the chip from somebody else when you can actually build your own? This is an easy example. We see a lot of people with the AirPods there. People are like, wow, they just miraculously connect. Well, they've built a chip that only does one thing, which is to make those AirPods work, or the Google Pixel phone, or a certain operating system in the car. So I was asking a semiconductor producer, like, what volume do you need before it starts to become affordable or meaningful to have a specialized chip? He told me if you're doing a run of around 50,000 for, say, a mid-market product, it may make sense. If you have a very high-end product, and you're selling a product for $1 million, you may actually say it may only have 1,000 units, right? So you need to think around, wow, are there things that I may want to have a domain-specific processor that I design exactly for my specific use case, so all that compute can be channeled there? And I may even take advantage of new architectures, new materials. In this case, this is a photonic chip. Right, it's one example. We've been talking about the end of Moore's law for 15 years, and as we can see from NVIDIA's stock price, it hasn't arrived yet. So now we're going between 2 and 1 nanometer production capabilities, but there's already a new generation of materials, 3D stacking, neuromorphic chips, photonic chips. So we see a diversity of new capabilities that are emerging. And again, we won't give all the answers here, but as you're thinking around your 3-year plan, 5-year plan, 10-year plan, think around what are the emerging exponential capabilities that are available to you, and how do you make sure that you don't go down a cul-de-sac of opportunities because you miss a transformational moment here. And then there's what I call novel chips. How many people are familiar with Neuralink from Elon Musk, brain-controlled interfaces? So this is an example of a chip there, right? Specialized chip just to manage a brain-controlled interface. We went from only 1 patient a year ago. This year there's over a dozen. Next year there will be over 100. We now see actually using brain implants to be able to return sight to people, return movement to people that couldn't move. And some people aspire to be able to actually augment our ability to think, or so on. I won't get into the ethical considerations of that, but again, what you see is a specialized, custom-built chip that's made for only one thing that brings in capabilities that in a previous era would have seemed magical. Lisadol. So this is from, what do you have here? Oops. This is 20, what was that? Well, if I go back to 1956, we had John McCarthy. Then we had the AI winter in the 1980s. And at the time, people thought we do symbolic computing, we do neuromorphic computing. And then nobody cared about AI, right? It was a dead end. And then you had Gary Kasparov in 1997 with Deep Blue competing in the chess match. Now in that case, they weren't using our deep learning AI. They used specialized chips. Like there's a specialized chip that was made just to play chess for that game. And it caught the public attention. Now, at the time of Gary Kasparov, people thought that the neural networks were dead. And then we have the match here with Lee Sedol in 2016. And all of a sudden, people are like, wow, this was thought impossible. Yeah, computers could play chess, but they would never be able to play Go because of all the number of possible moves that were in place there. And so it was assumed that it was an impossible problem until it wasn't. Again, I highlight this to signal that, again, things that we think are impossible or not doable, if we step back and reflect and, okay, what technologies might we combine? What progress that hasn't emerged yet might make that possible? It's something different. Now, a year later, you had 8 scientists from Google release the paper, Attention is All You Need. And then that paper went from that to ChatGPT that we know today. None of those people are still at Google, unfortunately, or maybe fortunately for them, they've all gone into other places. So you went from 5 years from research paper to product, 5 days from product to 1 million users, right? And you think any other business, how does that happen, right? And often we're wired, oh, if I do a research paper, it's going to take me 15 years, then I have to do a product market assessment and then come. But we're in an era that the speed is just moving extremely, extremely quickly, and we have to adapt to that. Quickly through these agents, we hear a lot about AI agents. They're here, they're variable. One of the things we see is that multiple agents can outperform a singular agent, right? And so this gives benefit if you have specialized data sets in your factory, in your organization. You may actually do better combining a SLM, a small language model, with a generic frontier model and creating a hybrid there. And then you can actually build specialized agents that are unique to your company and maintain a competitive advantage. I'd just argue that if you don't have competitive data, it'll be hard to have a competitive advantage in this space. So data becomes a very important resource when you're thinking around agents and how they interact. NeoClouds, this is a picture of Stargate in Abilene, Texas. I think we've all been following the massive investments going in there, and also the massive energy requirements that are required. So we no longer measure compute in number of semiconductors. We now measure compute in the number of gigawatts you need to power the power plant. And this is an area where Saudi Arabia has a competitive advantage to be able to participate in this economy. We've also heard that we're running out of data. Synthetic data sounds kind of odd, so I thought I'd do an example here. You take an image, and then you just rotate it 15 degrees, flip it around the other side, you turn the brightness down. You just basically give more for the model to be able to train upon, and so you're injecting synthetic data. Because otherwise, we've exhausted the cat photos that are already on the internet and the dog videos on that place. So we actually have to start manipulating and modifying them. Personally, I'm not concerned about running out of data, and I think this is relevant to manufacturing, because the next step is that you go to specialized foundation models. I should update this presentation. That's the problem when you make it the morning of the presentation. You miss a few slides. So. Specialized foundation models, I think the most popular one we should think about are world models in the context of manufacturing. So we actually start taking all that sensor data from those 1.5 trillion semiconductors and sensors that are being produced, and we can actually start analyzing and measuring the real world. And that's very different from what you can capture in language. And if you look at the next generation of robotics, you look at factory production, you look at all those domains, you'll need that. But you as well have it in domains, for example, in protein folding or in disease modeling, a lot of different things. You can have weather models. Right now, we actually start seeing to be able to make predictions about the weather. There's been progress in being able to anticipate the monsoon, and the AI models now can predict much better detail but they're a specialized thing. Again, they don't need cat photos to predict the monsoon, but they benefit from having specialized data on those elements there. Artificial general intelligence, I think this is something that a lot of people are concerned about. If you look at the main proponents of the companies that are raising funds, they'll tell us it's 1 year away, 2 years away. We've also heard that about that autopilot on some companies' cars, right? It's always 1 year away, and we're still waiting. When I talk to experts who aren't raising money, it looks like it's probably more 8 to 10 years away. Doesn't mean it couldn't arrive sooner, but it's unlikely that LLMs are going to get us there. And to this end, I'd like to just highlight a few caveats. This is a protest against AI in Germany, right? So you actually have people saying, I don't want your artificial general intelligence. I don't want your brain-controlled interface. And so we have to actually think around what are the social and economic frictions as we roll out new technologies. Is actually society ready for that? How do we actually make sure that when we bring these in, they're there? What are the limitations of the LLMs? I think LLMs unlikely to get us general intelligence. Okay, how do we take that into account? What else is there? And then most important in this is what people call the existential risk is on alignment. If the system gets intelligent enough, will it actually be aligned with our values, with our goals, with our objectives? And if it's not, what's happened? And if it's smarter than the people that are managing it. So I am a strong believer in AI. I think it's super valuable, but it's important that we also recognize that there's some caveats there and that we don't just rush in there. Anyone know who these two ladies are? Michelle Charpentier and Jennifer Doudna, receiving their Nobel Prize for their research on CRISPR. 2012, and again, the speed of which things are happening, went from 2012 to I think 2022, the first sickle cell treatment with CRISPR was done. In Saudi Arabia, I think had already done gene therapy treatments in 2016 before that. So we hear a lot about AI, we hear a lot about semiconductors, but the changes taking place in biotech are actually moving just as quickly. So here's an example of CRISPR. So for those of you who are not familiar, it's the ability to edit or modify a genetic structure. So if you think about your word processor, you have a text, you can come in, you can change some words, and then that's what CRISPR allows you to do. You're editing that capability. But there's also synthetic biology, and this isn't like, it's all still like the word processor, but instead of editing existing text, you write it from scratch. You give it the instructions on what you'd like to create, and then you can create anything there. I think this is another area that I don't want to get the numbers wrong, so I'll pull up a few numbers here. So a little bit of context. So we discovered the first DNA in 1953. 50 years later, we had the Human Genome Project at $2.7 billion after 13 years' effort. Today, that same sequence that cost us $2.3 billion with one of these machines can be done for roughly $80 with the lab test from home. So what does that look like on a log chart? Okay, 100 million. Now, we look at the most recent machine that came out earlier this year. It's now doing 10 to 12 reads per wafer or chip, allowing you to process 30,000 genomes per year. It's a 50% increase in just 1 year from when they released the last machine. Again, like the NVIDIA chips, but now happening in biology instead of in semiconductors. And that means now you can get down to $80 to sequence the whole genome, right? So in just a few years, from $2.5 billion to $80 with continued progress. And when you try and put that on the chart, I actually got this from the National Human Genome Research Institute. I went to get an updated chart to see what the latest is. With the government shut down in the US, they've stopped updating the website. So I had to mark it myself. And so the green star would actually take us off the chart. because the $80 is now below the line that they put it at. So we see this continued exponential improvement in capability there. Now, this is a young child here, and KJ was born in Philadelphia in 2024, and he had a personalized CRISPR treatment. So not a general one, like within the sickle cell case. He had a personal treatment for a rare disease. And this has actually allowed him to recover. So they thought initially he would die. Now, when people talk about rare diseases, they say, okay, this is something that there's not enough people with this disease for the pharmaceutical company to build a treatment for it. It's not justified there. But if you take, and I think in Saudi Arabia alone, there's around 300,000 people, maybe with the sickle cell anemia. For a pharmaceutical company, they say, is that worth our time? Maybe, maybe not. But every one of those individuals is a life. And if you take all the rare diseases globally, it's estimated that there's 350 million people with a rare disease. Doesn't look so rare anymore, right? There are different variations of it. So now these tools can actually allow us to treat them individually, because what might have cost us $2.3 billion before has fallen to 80. I don't know the cost of the treatment here. I suspect it was still really high. But with the compounding capabilities, the research, and the knowledge, we can actually start to treat those individual cases one by one. Bioprinting, biomanufacturing. So manufacturing isn't only for hard goods. You can actually, this is a case of producing chicken meat, extract the cells, put the cells into a bioreactor, out comes a product. Different people have different opinions on this, but you see actually you need much less energy. There's much less water utilization there, and you do see places that this becomes a norm. Similar to when we first started desalinating water, people said, why would I run water through a desalination process? And yet it gives you fresh water, and I think we'll see things also happening on this in the domain of biomanufacturing. Last area I would just highlight, AI discovery. This is an example from AlphaFold 3, doing the protein folding. And again, this wasn't possible a few years ago, and that was able to gain Demis Hassabis the Nobel Prize there. And so if you look at where Jennifer Doudna was, their research on CRISPR in 2012, and now where we are today with AlphaFold 3, and now we go from modeling proteins to enzymes and all matter of other domains. Energy, everybody in this room knows energy better than I do, so I'm going to go very, very quick. This is a plant in Andhra Pradesh, Renew Power. The reason I highlight it is because it was an award winner for our Advanced Manufacturing Lighthouse program. And I met with the CEO. He asked his team to apply for the Advanced Manufacturing House. They sent in their submission. The team said, there's nothing special here. The CEO said, we were rejected. I thought we were doing really best-in-class work. So he sent the team back again to say, why didn't we win the award? They went through and they reviewed all their processes, and then they came back and applied again. And when they came back the second time, they were using drones to inspect their propellers. They had a centralized data center that they can manage the whole network. I know Dammam has something similar there, but the capabilities that were once exclusive to an organization this size or skill, Saudi Arabia, can now go to a mid-sized company in a developing country and become available to them. And that reduced their cost, allowed them to deliver energy. And so this is then where we see wind having reduced in costs by around 90-95% over the last 15 years, solar improving more rapidly. Now, when you combine that with batteries and storage, this is a company out of Chongqing, China. They've recently reached an agreement in Saudi Arabia to actually start using Saudi solar capacity, but then able to have storage to back that up. Again, this is an area that you're seeing improvements of 100% a year. It was, I think about 5 years ago, they said, okay, at $100 per kilowatt hour, a electric car becomes cost competitive with the internal combustion engine. Today we're below 50, and we see a clear path to get to around $25. And while the friends in the US are letting this aside, the Chinese are using this to their advantage to build out an electrical mobility and transport system, harnessing these declining costs in these battery technologies there. People forget grids are important. Yeah, you can generate the energy, you also have to move it. You need it where you want to consume it. So we shouldn't forget that. China State Grid has some of the best superconducting capabilities there. So they're trying to figure out how they can get energy from Qinghai, from Xinjiang, and move it to the coastal areas. So they're doing their compute to build their frontier models close to the data, and then using high grids to do inference level compute, which is for the applications close to the cities. Small modular reactors, fusion. Fusion is one of those domains that's always seemed far away in the future. I visited a company called Commonwealth Fusion in Massachusetts earlier this year. I asked him what his biggest challenge is. Like, I'm thinking, okay, do you don't have enough plasma physicists? You know, what is it? I'm missing pipe fitters and electricians. Those are the two biggest constraints on building my nuclear reactor. Google has already signed for offtake on that. I wish them luck. I think they want to do a first dry run this month on the systems. They want to have an actual fusion reaction next year. They've already raised 60%, I think, of global funding that's gone into fusion companies. If they hit those targets, they'll raise a lot more, and we may see the next NVIDIA there, or maybe not. And last, I would just highlight carbon capture and storage, direct air capture. When I mentioned we're on path to go 2.4, 2.8 degrees, we will need to draw down carbon from the ecosystem in the future. Direct air capture still very, very expensive. $500 a ton. That's not reasonable, right? If you're trying to lift somebody out of poverty, we talked about the migration, the growth rates in those 5 countries in Africa that are helping drive that. Doing that effectively at $500 a ton won't work. So we also need to look ahead and think around what are the solutions and investments that need to be made in CCS and direct air capture. Unfortunately, they're on linear curves and not on exponential curves. But if we could find the solution to make these exponential, it's something that would be very valuable to the world. Quantum economy, quantum computing. This is a picture of a quantum computer. Again, first science done in the 1930s, relatively slow rate. We had an announcement from Google this week that they saw a 13,000x improvement with their latest Willow chip. Expectations are 2028, between 2028 and 2030, that we're likely to have a functioning, practical quantum computer. And it seems that all the math and engineering is in place, but it'll need to carry forward. If that's achieved, it means we also have to think about quantum security. It's estimated that you'd need about 2,000 to 6,000 qubits to crack most encryption on today's systems. There are some intelligence agencies and organizations globally that are already storing data with the intent to encrypt it earlier. And unlike our announcement from Google or the press release from NVIDIA, I don't think anybody's going to announce it when they have the capability. They'll first start with decrypting the data. And so I share this because whatever business you're in, you need to think around quantum secure solutions today, and that way we avoid a Y2K moment. It's not here yet, but it has strong potential to come in the next few years. Quantum sensing, this is an example of quantum sensing in healthcare. There are quantum solutions today, not quantum computers, but there are things that are using quantum effects. And it's something that if you're in medical devices, if you're in resource discovery, you can actually start thinking around, okay, how can I use these quantum sensing capabilities today? This is Ursula von der Leyen's jet. They landed it in August when she was flying in Europe. Said somebody was jamming the GPS. At the time, they blamed it on the Russians. There's a debate whether it's the Russians or not. I have no idea. But pilots thought their GPS was being jammed. That's actually quite common in the region. It seemed new in Europe, but in the Middle East, this has been going on a long time. A lot of different actors there. You actually have quantum solutions today. They're still big, about the size of this podium here, that you can actually then, even if the GPS is down, you can then actually still have a kind of quantum navigation to know your point using a very refined magnetic map and looking at quantum effects. Quantum communications, this example from China. They've done a secure satellite communication from China to South Africa over 10,000 kilometers. And in a geopolitically intense and fraught world, having secure communications becomes important. And so it's another domain where quantum can help us. Hopefully you know your Saudi counterparts there. This is on Axiom Space. So amazing thing about technology is today you don't have to own the full stack, right? You didn't have to own your own rocket. You don't have to own your own launch capabilities. And so today there's over 85 countries that are able to participate in the space economy without necessarily having the full vertical stack there. We see 3D printed rockets. This is one from Relativity. Eric Schmidt, longtime CEO and chair at Google, recently bought this company because he said, well, Elon Musk has a monopoly on launch with SpaceX. Maybe there's a market here. And so he's invested in that recently. Reusable rockets. This is an example from Axiom Space. They'd like to build the first private space station. So in the same way that SpaceX has been able to reduce costs by over 90% per kilo launched into space, what if you do that for the space station? So it may be that the next space station isn't a government-led effort, but a private-led one. In this case, Axiom. Earth observation, just in the same way that we've had falling launch costs, improved algorithms, improved sensorial capabilities, means that many things today can be done more cheaply from space than they can be terrestrially. You can monitor power lines. In this case, this is hyperspectral imaging. So if you're at Modin, you can use hyperspectral imaging to look at what the likelihood is that there may be different type of resources under the Earth and actually accelerate speed of discovery in that space. Orbital data centers, there's a lot of space here. They're running out of space in US. I think Elon Musk wanted to build his gigafactory for compute in Tennessee. They said no. He went to Memphis. Now there's companies looking to say, okay, can I actually move my data center to space? Scale's deceptive here. This is meant to be 4 kilometer by 4 kilometer solar array, beaming data back using the Starlink system. They're going to launch a chip in November. So we'll know soon how they do on that front there. Last, again, manufacturing, in-orbit manufacturing. This is a test. You can manufacture things in space that you couldn't in Earth. Fiber optic cables, medical materials. So if you're thinking around really high precision manufacturing pieces, this is a place to look at and explore there. So the future is already here. It's just not evenly distributed. November is already here in October. So we get a sneak peek on that. What's that mean for advanced manufacturing, connectivity, integration, intelligent self-learning systems, automation, autonomy, end-to-end collaboration, integrated sustainability, cybersecurity? I'll pause there. I know there may be some questions or discussion we'd like to do with the group. Want us to help keep us on time. So thank you.
I'd like to open the floor for 1 or 2 questions.
We still want to hear Kermit's take in terms of applications to Saudi.
Yes.
So we can do the questions or leave it at your disposal, but we'd love to hear that.
Okay. Can we get the slides back on if that's okay? So this is advanced manufacturing. One I would just like to touch on, because I know one question I hear a lot. Do I want to do sustainability or efficiency? These aren't competition. You get efficiency by focusing on sustainability. Anytime you hear friction, anytime you have excessive heat, anytime you have excessive noise, it means you have an inefficiency. That's an opportunity to actually reduce power consumption, to deliver products faster, to reduce wear and tear. So what we've seen is that factories that are focused on sustainability, actually it drives efficiency. It's not necessarily a trade-off. Now, in the context of leaders, since we're here, think the whole system, not just one technology. Look across the whole ecosystem. Constantly scan what's happening on the strategic periphery. Like, follow these kinds of areas that we highlighted today, understand what's happening. Always keep humans first and center. Ultimately, technology is to benefit people, to benefit society, not for the economy. We need to be resilient when things are changing so quickly. And how do you have this exponential mindset in place? Now, these I make as recommendations. This I'm a little bit more. I say consider. I want to be very humble here. I think first and foremost is, again, reinforcing putting people first. And I think a lot of the challenges that we see when technology fails is somehow we've put profit, we've put speed, we've put efficiency ahead of people. The technology is going to continue. But by keeping people at first, I think then people also embrace it, they'll integrate it, and they can harness it to create shared prosperity. Public-private cooperation, absolutely essential for the private sector and public sector to move together. These things are moving so quickly, the regulators can't regulate it. And regulation looks backwards. It's in the rear view mirror. Business leaders look forward. They project forward. So we need that cooperation, that the regulation is also agile, that you manage for the outcome, not the process, right? So what's the end objective here? Don't let me figure out how I want to do it. And we have some boundaries and leave some flexibility there. We had the announcement from President Trump. He looked much happier on stage alongside President Xi. 1-year agreement. President Trump told us that it should continue. They can imagine rolling that over. I think if you're here in Saudi, yes, US, great partner. China, also really important. But looking beyond, again, we're in a large planet here, and a lot of countries don't want to be forced to choose between US and China. And Saudi is a critical global player, is a positive partner for many countries around the world, and I think that becomes a competitive advantage. Securing technological autonomy. We'll hear a lot, especially in Europe, about AI sovereignty. I personally think sovereignty is a myth. These supply chains are so complex that you lose the benefits if you try and do everything yourself. At the same time, you need to be very focused on, well, where do you want to differentiate yourself? What does that mean? Where do we need autonomy? How valuable is it? How do I have redundancy in my systems and my processes? This is just good business sense anyways, but it becomes particularly important when we think about these technologies in place. And then last, I think, again, Saudi is already doing an amazing job at this with the leadership here in the kingdom, but how do we harness these exponentials across all the different domains? These are some of the things I observe as a visitor coming in. And again, I'd like to commend all the leadership here in the kingdom, because it's one of the reasons I like to keep coming back, is to see the progress that's being made on these topics. So thank you.
Thank you, Mr. Jeremy Jurgens, for the insightful discussion.